Welcome to Creative World. Now I am solving exercise problem number 18. The formulas which will be used in this scenario is electric current formula, which is the derivative of charge with respect to t, energy formula, which is the multiplication of current, voltage and time, and straight line equation, which is being used in earlier scenarios. First, read the scenario. The charge entering the upper terminal of box in figure 1.18 is shown below. How much energy is absorbed by the box between 0 and 9 seconds? This is the box and the charge which is entering to the box is plotted here. In figure 1.18, voltage across the box are 12 volt and we need to calculate the energy absorbed by the box between this time interval 0 and 9 seconds. Firstly, we will be using straight line equation because we have some straight lines in this plot of charge. Secondly, we have 12 volts. Okay. In order to calculate energy, first we should have the value of current. We have the plot of charge. From this graph, we can calculate the current. So finding out the current between time interval 0 and 1 second, our initial points on this graph will be x1 is equal to 0 and y1 is equal to 1, and our final points will be x2 is equal to 1 and y2 is equal to 0.5. Entering these values in straight line equation, which is this, on y-axis we have charge and on x-axis we have time in seconds. Entering these points into this equation, we got the value of charge between 0 and 1 second is equal to minus 0.5 t plus 1 coulomb. In order to calculate the current, we taken derivative of this charge and we got minus 500 milliampere. Similarly, the current between 1 and 2 seconds, the charge is not changing, it is constant 0.5 coulomb. So as we know that the derivative of a constant is 0, so between 1 and 2 second the current will be 0 milliampere. Between 2 and 3 second, our starting points are 2 and 0.5 and ending points are 3 and minus 1.5. Putting these points in straight line equation, and we got the charge value is equal to minus 2t plus 4.5 coulomb. Taking the derivative of this charge equation, and we got current is equal to minus 2000 milliampere. Now calculating current between time interval of 3 and 5 seconds, our starting points will be 3 and minus 1.5 and our final points will be 5 and 0.5. Entering these points into the equation, we got the equation of charge equal to t minus 4.5 coulomb. Taking the derivative of this charge, we got current between 3 and 5 seconds is equal to 1000 milliampere. Calculating current between 5 and 6 seconds, our starting points are 5 and 0.5 and ending points are 6 and minus 0.5. Entering these values into straight line equation, we got the equation of charge between 5 and 6 second is minus t plus 5.5 coulomb. Taking its derivative, the derivative of t will be minus 1 and the constant derivative will be 0. So minus 1 ampere, which can be written as minus 1000 milliampere. From 6 to 7 seconds, the charge is constant minus 0.5 coulomb and its derivative will be 0. So the current will be 0 milliampere. Current between 7 and 9 seconds, our starting points will be 7 and minus 0.5 and ending points will be 9 and 0. So the equation of charge will be 0.25 T minus 2.25 coulomb and its derivative will be 250 milliampere. Here is the plot of current with respect to time from 0 to 9 seconds. Now we have current between different time intervals and voltage as well. So we can calculate the energy. Energy between 0 and 1 seconds, voltage which is constant 12 volt, current which is minus 500 milliampere multiply by time difference between these two chunks of time which is 1. So the energy will be minus 6 joule. Here I want to mention that this current is milliampere. That's why energy became minus 6 joule. Between 1 and 2 seconds current is 0, energy will be 0 joule. From 2 to 3 seconds current is minus 2 ampere. Energy will be minus 24 joule. 3 to 5 seconds current is 1000 milliampere and the energy will be 24 joule. Here the difference between time 3 to 5 seconds is 2. That's why 2 is multiplied. Here the differences are 1. 5 to 6 second difference will be 1 second. Current is minus 1000 milliampere and voltages are 12, so the energy will be minus 12 joule. 6 to 7 second no current is flowing, energy will be 0 joule. And from 7 to 9 seconds current is 250 milliampere, energy will be 6 joule. Here again time is taken 2 seconds because of the difference of this time. Here is the plot of energy between 0 and 9 seconds. Thank you. See you in next video.